Chapter 5. The Waste Pipe. Introduction. In the study of plumbing, it is important to know the different parts of the piping installation and their functions. The effectiveness of plumbing installation depends upon the strict observance of natural laws of nature, such as gravity and the atmospheric pressure that affect the whole system. Most of the failures encountered in plumbing installation were due to the non-observance of these natural laws and the grave abuse of its function. Generally, waste pipe is smaller in size than the soil pipe. Smaller because of the kind of waste it receives from the various plumbing fixtures. Among the suspended materials found in the water waste are grease, lint, matches, hair, garbage, and many other objectionable substances. Plumbing fixtures are too often misused. Household refuse of all kinds are carelessly disposed of by flushing them through the plumbing system. Indeed, the improper use of plumbing fixture can only result in waste line stoppage and deterioration of the pipeline. The drainage installation of a plumbing system comprises three major component parts: the drainage, the waste, and the vent, or simply called DWV. The drainage pipe refers to an installation that receives and conveys discharge from water closet with or without waste coming from other fixtures. The waste pipe is any pipe in a drainage installation that receives the discharge of any fixture except water closet and conveys the same to the soil branch, soil pipe, or house drain. Fixture refers to slop sink, lavatory, urinals, bathtub, and the like except water closet. The vent pipe in a plumbing system function as air passage or conduit to ventilate the drainage and waste pipe installation. As already discussed, solid human waste is discharged by water closet only to either the soil branch, soil pipe, soil stack, or house drain. Categorically, any pipe that receives and conveys human waste is affixed with the word soil, such as soil branch, soil stack, etc. Soil branch refers to a horizontal pipe affixed by the word soil. The word soil connotes a pipe receiving discharge from water closet. On the other hand, if this soil branch does not receive discharge from water closet but from other fixtures only, it will be classified as waste pipe. Soil stack is a vertical pipe installation where the soil branches terminate. The pipe is called stack being installed vertically, and the word soil is affixed because it is receiving human waste from soil branch. Otherwise, it will again be classified as waste stack. When a waste pipe is not directly connected to a soil stack or house drain, it is called special waste. General condition for a good waste pipe installation. 1. By making the right choice of materials. 2. By conservative use of fittings. 3. Right location of the cleanouts. 4. Right slope or grade of the pipelines. 5. Using the right size of pipe. 6. Correct manner of joining the pipe, and 7. Providing stable and rigid support. 2. The right choice of materials. The material intended for waste pipe installation could be well selected from those that were enumerated in Chapter 2. The character of the waste to be drained and the service to which it is intended for dictates the kind of material to be used. For instance, any waste pipeline that conveys large amount of acid must specify acid-resistant material, example of which are fixtures serving chemical laboratories, plating, engraving establishment, and others that uses acid of various kinds. Refuse that are coming from domestic and commercial kitchen contains acid of different kinds, but considerably in small, negligible quantity and therefore does not require the use of an acid-resistant pipe. 3. Conservative use of fittings. The smooth flow of waste inside the pipe is a primary consideration in all type of plumbing installations. Most of the waste pipeline failures were attributed to unwarranted use of accessories and too many fittings, or because of using the wrong type of fitting in a given location. Conservative use of fittings refers to the right choice of the right kind of fittings for a particular change of directions, turns, or offsets. Injudicious use of fittings should not be allowed in plumbing installations. Shortcuts that will not allow smooth passage of waste should be avoided. Pipe joints and fittings were specially designed to make smooth changes of direction, turns, or offsets, but sometimes their application may not be in accordance with the purpose for which they were made. There are many self-proclaimed plumbing experts who install pipe in what they call shortcut method. The correct use of joints and fittings were not properly observed. It is maybe because they are so in hurry of work and their pay as well. But the question is, how sure are we that the installations are clog-free? Pipe installation that fails or break too soon may have been due to any of the following causes. 1. The use of too many fittings, and 2. The use of wrong type of fittings. Recommendations. 1. Do not use short ratios fitting on a vertical to horizontal direction or horizontal to horizontal changes. 2. Use long sweep fitting on horizontal changes. 3. For vertical to horizontal direction of changes, the Y and 45-degree fittings are most appropriate. 4. The T fitting was designed for vertical run with lateral branches only. Its use on horizontal installation will create a tilted or crooked joint connection, called premature waistline defect. Figure 5-2 shows premature waistline defect and vertical to horizontal changes. 4. Location of clean out. The waste pipe installation must be provided with an ample radius of clean out, strategically located to be opened in case of pipeline trouble. Clean out is a receptacle of the plumbing system accessible on floors, wall, or ceiling. It is equipped with a plug or flush plate so designed as not to impair the aesthetical view of the room. The location of clean out must be indicated in the plan. It should be size equal to the diameter of waste pipe where it is to be connected. This is to avoid interference in the rodding or cleaning process. Clean out must be readily accessible to the plumber in case of waistline stoppage. 5. Right slope or grade of waste pipe. The ideal position of horizontal waste pipe were those installed at 2% slope, meaning the pipe was installed with an incline ratio of 2 cm per meter length. For instance, a 3-meter pipe installed as a waistline will have inclination of 3 times 2 is equals to 6 centimeters. Waste pipe must be of sufficient diameter to afford adequate velocity of flow in order to make them as nearly self-scouring as is practical. The latest scientific test and experiment conducted by the National Bureau of Standards sponsored by the Housing and Home Finance Agency showed that wet venting and stuck venting are safe in certain type of installation. The experiment revealed that the trap seal loss occur when the grade or slope of the incline increases from 2% to 4%. Figure 523 shows the right slope of pipe. Trap seal loss means the loss or escape of standing water inside the P-trap. This is usually caused by siphonage induced by rapid flow of waste inside the pipe. It is also referred to as water seal escape. Plumbing installation usually suffer grave abuse of function brought about by human element. Record shows that waste line identically designed with the same size and grade installed in different residences but used by different person functions differently. The materials and method used in food preparation plus the habits of the housewife accounts for this. Some people use plumbing fixture as a means of getting rid of almost any kind of unwanted waste. Waste such as garbage, grease, hair, lint, matches, cigar, paper, and the like are found in most clog waste line. Take note that plumbing installation are not intended to convey materials of this kind of unwanted waste. 6. Manner of joining pipes. Injudicious connection of fittings should not be permitted in any plumbing installation. Each kind of pipe has its own manner of joining recommended and specified by the manufacturers. For instance, cast iron pipe are joined by the use of oakum and lead at the end hub and spigot connections. Likewise, plastic pipes clearly specify the use of solvent plastic cement or by special fitting connector. Remember that any alteration or deviation from the manufacturer's specification will only endanger the effectiveness of the pipe joints. 7. Determining the size of waste pipe. The National Plumbing Code on the size of waste pipe provide that the waste pipe diameter shall be adequate enough to serve the installation of fixture in a general way, but the best way is to fit the diameter of commercial pipe into the fixture pattern in the most efficient manner. The size of waste pipe intended to receive waste from the fixture must be of sufficient diameter. This is to accommodate the velocity of flow, making them as nearly scouring as necessary to prevent the silting of the pipe. Scouring means the flush or wash out to remove dirt or grease by flowing through. There are those who believe that by making the drainage pipe larger than what it is necessary will increase its service efficiency. This belief without scientific basis has triggered disagreement among the people in the plumbing industry. Disagreement on this matter, however, was resolved when the Uniform Plumbing Code Committee formulated data as guide and references in determining the size of the waste and other drain pipes. The data formulated by the committee for incorporation in the plumbing code were product of countless tests and experiments conducted for years. In addition, installation experiences that were proven satisfactory in service compiled over a long period of time were also incorporated. The Uniform Plumbing Code Committee's findings are enumerated briefly as follows. 1. By increasing the size of the drainage pipe does not guarantee effective scouring action or self-cleaning ability of the pipe. Self-cleaning ability is present when the liquid and waste inside the pipe flow smoothly and simultaneously together. 2. Water flow inside the larger pipe is relatively shallow. The solid waste does not flow on shallow water but tend to remain at the bottom of the pipe. This is practically the most common cause of many clogging problem of drainage installations. 3. Drainage pipe must be of the right size to have a liquid flow of about 50% of the pipe diameter, meaning that the flowing water inside the pipe must have a depth equal to 1/2 the pipe diameter. 4. For instance, if the pipe is 100 mm diameter, the water flow inside the pipe must have a depth of 50 mm to attend the scouring action. This is where the 2% slope become effective. 5. On the other hand, too many pipeline is subject to overloading of flow. The tendency is to create back pressure, siphonage, and floor flooding. 8. Fixture unit. The National Plumbing Code strongly endorsed the use of fixture unit value as waste load in determining the size of the waste pipe. The Uniform Plumbing Code Committee conducted numerous tests on various plumbing fixtures in order to determine the amount of water each fixture discharges in 1-minute interval through their outlet orifices. Table 5:1 shows the fixture unit values. The test result showed that the wash basin, being one of the smallest fixture, discharged waste at approximately 1 cubic foot of water per minute interval. Based on their findings, the committee finally decided to establish the unit fixture and called the water discharge as 1 fixture unit, representing 1 cubic foot or 30 liters of waste discharged by the fixture in 1-minute interval. Table 5:2 shows the size of horizontal fixture branch and stock. With the information just discussed and the data presented in Table 5:1, the student must be familiarized with the relation between the fixture unit values and the size of drainage pipe required. How to use Table 5:1 and Table 5:2. One must determine first the number of each fixture involved, multiplied by the corresponding fixture unit in Table 5:1. Then refer to Table 5:2 for the size of the pipe. Illustration 1. Determine the size of a horizontal waste pipe to serve 5 urinals, 3 lavatories, 8 showers, and 2 slop sink. Solution. 1. Find the fixture unit load of the above fixture. Refer to Table 5:1 and multiply. 5 urinals times 5 units is equals to 25 units. 3 lavatories times 1 unit is equals to 3 units. 8 showers times 2 units is equals to 16 units. 2 slop sinks times 3 units is equals to 6 units. Overall total of 50 units. 2. Refer to Table 5:2. Under the column of 1 horizontal branch, 50 units could be well served by a 100 mm or 4 inches pipe. Comments. Examining Table 5-2 under column diameter of pipe and one horizontal branch, it seems that the 100 mm or 4-inch pipe with a capacity to serve 160 fixture unit load is too large to serve the 50 fixture unit as computed. However, since 50 fixture unit fall under the parameter of 100 mm pipe as formulated by the National Plumbing Code, it has to be followed without question. Specify the use of 100 mm pipe diameter. Your plumbing design, particularly the sizing of the pipe, should be determined by the way of mathematical computation using the fixture unit values. However, regardless of the result when it is smaller than what is promulgated by the Plumbing Code, as presented in Table 5-1 and 5-2, the code must prevail. One probable solution for a person who is thinking of economy is to install a graduated size of pipe from say 30 to 100 mm diameter in order not to violate the provision of the code. The idea is very good and acceptable on the premise of economy. However, it should be analyzed carefully considering the cost of cutting different sizes of pipe, providing reducers and various fittings, plus the time delayed and the high cost of labor. Otherwise, we might as well forget the idea toward unrealistic economy. Illustration 2. Determine the size of a horizontal branch waste pipe for one lavatory, one residential sink, and one slope sink. Solution. 1. The problem is to determine the size of the pipe that could effectively convey waste coming from the three fixtures as enumerated. 2. Refer to Table 5-1. Solve for the total fixture units. 1 lavatory is equals to 1 unit. 1 residential sink is equals to 1.5 units. 1 slope sink is equals to 3 units, total of 5.5 units. Referring to Table 5-2, under column 1 horizontal branch, the 5.5 fixture unit is nearest to the value of 6. 4. Under column 1, a 50 mm pipe will be satisfactory to drain all the three fixtures. Use 50 mm diameter. To compute the size of each fixture drain is not necessary because the manufacturer has already provided each fixture with the right size of drain. Most plumbing installation frequently suffers from the grave abuse of functions by human elements and behaviors. Some people think and regard the installation as a means of disposing almost any kind of unwanted waste. On the other hand, people who observe proper disposition of the refuse seldom experience waste pipe problems. 9. Waste pipe and other fixtures. Waste pipe is classified into two types, depending upon the kind of fixtures it will serve. 1. Direct waste, and 2. Indirect waste. Direct waste is one with terminal directly connected to the plumbing system. Figure 5-4 shows direct waste. Different types of fixture served by direct waste. 1. Urinals. A. Pedestal. B. Stall. C. Through. 2. Bathtub. A. Silts. B. foot, C. bidet. 3. Lavatories. A. Wall hung. B. Pedestal. C. 2 pieces. 4. Sink. A. Kitchen. B. Pantry. C. Slope. 5. Showers. A. Single stall. B. Gang. 6. Drinking fountain. 7. Laundry. 8. Laboratory. 9. Hospital fixture. Indirect waste refers to a connection with terminal not directly connected to the plumbing system. Fixtures served by indirect waste are 1. Soda fountain. 2. Bar waste. 3. Refrigeration. 4. Drinking fountain. Figure 5-5 shows indirect waste. Recommended size of waste pipe. For a particular fixture, either served by direct or indirect waste, recommend the following sizes. 1. Sink waste. The minimum size of waste pipe for sink is 38 mm or 1.5. But because of the material suspended in it, the practice is to use 50 mm or 2-inch pipe. The National Plumbing Code provides that the waste pipe must be short, direct, free from offset, and provided with ample cleanout accessible for repair. 2. Slop sink is tapped either on floor or walls. Traps on the floor shall be 75 or 100 mm, and 50 mm for trap installed on wall with a clean-out plug. 3. Scullery sink, 50 mm. 4. Pantry sink, 38 mm. 5. Factory wash-up sink, 50 mm. 6. Bathtub, 38 mm minimum to 50 mm. 7. Lavatories, 50 mm. 8. Shower bath, 50 mm. 9. Urinal, 50 mm. 10. Laundry tub, 38 to 50 mm. 11. Drinking fountain, 32 mm. 12. Lavatory waste, 50 mm. 13. Hospital fixture, 50 mm. It is interesting to note that some fixture could be served well by using waste pipe of smaller diameter based on the volume of water it discharges in 1 minute interval. The code, however, regulates the size and size of pipe drain to maintain good sanitation through an efficient drainage system. One example is the urinal, wherein large amount of foreign materials are dumped and subsequently lugged into the short run of the pipe. Examples of foreign material that are found in clogged pipe are gum, cigarette butt and filters, matches, and many other. Likewise, the chemical action of uric acid of urine produces gelatinous substances that settle down and become objectionable sediments, which are difficult and extremely hard to remove. This is only one of those so many reasons why the Standard Plumbing Code Committee issued limitation on the diameter of waste pipe to serve plumbing fixtures. Generally, the 50 mm pipe is required for all type of urinals. End of Chapter 5.